Hello guys, my name is Deo Kumara Sanna Punniswaran and my matrix number is 24DKM 21F1161. Today I'm over here to explain about my group's case study, which is DJM40082 Programmable Logic Control Problem Based. So my other two group members are Oyan Jala, which is 24DKM 21F1131, and last is Mohammad Shafi bin Zakaria 24DKM 21F1041. Thank you. As you can see, now I'm going to talk about the problem identification for my group's case study. It's about how to address this condition. We need to create software that can automatically cut off all the current after few hours or seconds. As you can see, PSC is a middle person which will act as a main thing over the system and to the controller as well. So it's very important because nowadays everyone goes to workshop but they forget. So that's our case study, that we should ensure that most of us can shut down this automatically without using anything such as manually. Thank you. Yeah, as you can see, now my team and I going to propose automated solution for this problem. It's just very simple. This PLC program will ensure that we put 1 hour in the program, and after 1 hour the current will automatically turn off by the PLC, which is mean you don't have to use it automatically. It will preserve more energy and it will ensure in the laboratory or workplace, because if it's on for a long time, maybe it can cause electric shock, or even the laboratory or workshop can be harmed and can be burned because of any electric shock. So this kind of PLC software is very more important for us. Thank you.
And this is our PLC programming. And this is the video for our PLC programming. When we're switching on the push button, it will transmit the sequence to the internal relay. After that, the internal relay will keep the sequence and reset it. For the second one, when the internal relay has accepted the sequence, it will continue sending to the timer. The timer will control the time for active electrical current. After the timer countdown, the timer will send the sequence to T000 and it will send to the 0.03 relay. When the relay has accepted the sequence, it will send back to the first run for a normally closed switch, which is 0.03, and the current will be deactive. I/O table, PLC I/O address function. First input 0.00 function start push button. Second input 20.00 internal relay. Third 0.03 stop button. Output 0000 timer, and the last 0.03 relay.
Implementation plan. This is step-by-step for implementation plan of our PLC automation system. Number 1. System overview. Define the purpose and scope of the problem identification. Make an automation solution to solve the problem identification. List all the components involved like PLC. Number 2. Requirement analysis. Identify input and output. The input we use is start button, stop button, internal relay, and output is timer and relay. Number 3. PLC selection. Use a suitable PLC model with its CS1 programmer version 9.4. Number 4. Hardware installation. Install and figure out the PLC hardware. Connect the sensor to PLC's input and output module. Number 5. Software development. Design the ladder diagram. Implement error and handling and fault tolerance mechanism. Number 6. Testing and debugging. Conduct the initial testing of individual components. Debug the PLC program to ensure it is correct functionally. Number 7. Integration testing. Integrate all system components and test their interaction. Number 8. Simulation. Simulate different scenarios to validate the system response. Number 9. Create comprehensive documentation for the PLC program. Include I/O maps and detailed description of the control logic. Number 10. Training. Provide guidance on troubleshooting and handling common issues like overheating. And number 11. Maintenance plan. Develop a routine maintenance plan for the PLC and associated components. Project documentation. Number 1. The challenge we face is to make a ladder diagram to solve our problem identification based on our knowledge that we learned in PLC classes. Number 2. Other than that, if we confused on how to build the ladder diagram, we research the video from YouTube about PLC lesson so that we can learn it as many times as we want until we understand it. Testing and evaluation. Number 1. After testing the PLC programming, we noticed that there was no error in our PLC program. Number 2. All the PLC programming was functioning correctly. Number 3. The PLC programming completely solved our problem identification, which is to stop functioning for 1 hour. After that, the machine will turn back and ready to use. Number 4. That machine is fully in safety for students to use it.
Conclusion. After we complete this case study, learn many things from it. Firstly, we learn how to make a problem identification and solve the problem. Secondly, we learn the inventory of the components that we use to solve our problem identification. Next, we know how to construct the leader diagram and PLC, I/O, and CS programmer version 9.4 software. After that, we simulate our leader diagram to know if the leader diagram has an error on it. Next, we are evaluating the PLC program to know that it is entirely safe. Last but not least, we expect that the next generation will enhance our PLC programming, which has new components in that area that are more efficiency to use.